So the RTX-1 is an adaptive optics flood illumination ophthalmoscope. It provides cellular resolution images in 2 seconds acquisition. As by September 2020, 12 groups had used it to investigate 14 different types of IRDs, and their findings were reported in 37 publications. So in all the IRDs under study, the RTX-1 revealed microscopic signs of pathology that were not detectable with other ocular examinations. Of course, in 5 minutes, I will not have time to present in detail all the findings. So I will go straight to the main points and give some examples. So first, about the cone mosaic. Cone mosaic phenotypes could be visible on RTX-1 images. Indeed, different kinds of alteration in the cone mosaic were observed in different kinds of IRDs. To illustrate, I'm going to show some images and I will describe them with the terms used in the publications. So first example is cone disappearance with blurred areas, as observed in this CACD case. So outside of the blurry areas, the cones are visible as small patches. Note that this patient was asymptomatic. Then in this OMD case, we also have cone disappearance, but instead of blurred areas, we observed what Katharina Stingel called starry night cone pattern throughout the macula. This pattern seems to be typical of OMD, according to previous presentations. Then a different phenotype is cone disappearance with distinct foveal cones, like in this Stargardt case. So this image shows an abnormally low cone density in the fovea and almost no cones in the parafoveal area, where the RPE pattern can become visible. So here I can see some RPE cells around here. I don't know if you can see it, but I do. Now in this bestrophinopathic case, we also see distinct cones in the fovea, but compared with the previous case, in the parafoveal areas, the cones are still there, at least some of them, and they are hyporeflective. So apart from the cone mosaic, other pathological alterations in the retina were observed at the microscopic scale. A striking example is this ADOA case with microcystic structure in the inner retina. So these bubbles, these microcysts, were visible with the RTX-1 even when they were not detectable on OCT-B scans. And in foveoschisis, folds on the surface of the retina could be imaged with high details with the RTX-1. And the RTX-1 images revealed smaller folds than those that could be seen on color fundus images. Now let's go back to the cone mosaic. So the RTX-1 enables analyzing it quantitatively to obtain metrics like cell density. When evaluated on groups of healthy volunteers, the parafoveal cone density was consistent with previous findings from histology and AOSLO. In comparison, cone density was significantly reduced in almost all IRDs under study. What is even more interesting is that at least 6 studies reported a reduction of cone density that was subclinical. It means that the cone density was reduced even in some patients who had still good visual acuity or otherwise normal ophthalmological findings. A striking example is this family with cone rod dystrophy. So the patient's younger sister, she had BCVA of 0.7, but normal fundus and FAF images. The photoreceptor lines on the OCT-B scan were slightly disrupted, but what is interesting is that the cone density as evaluated from the adaptive optics images, it was significantly reduced compared to the data from normal controls. Then the last point that I would like to outline in this presentation is about longitudinal data. So far, 5 studies reported follow-up imaging of IRD patients with the RTX-1, and the most recent one is about late-stage RP. So this is the image of the macula of a patient with late-stage RP. OCT confirmed that this central zone with nicely delimited borders is actually remaining photoreceptors. Over the years, we can see that this zone, the size of this zone is shrinking. Even though on the same period of time, the visual acuity, which is indicated in yellow here, green here, did not reduce. So it means that the adaptive optics imaging enabled more sensitive assessment of the retinitis pigmentosa progression than the visual acuity measurement. And what is even also remarkable in this study is that RP progression, as detected with adaptive optics, seemed to be very steady across patients. So to conclude, since the RTX-1 was CE marked in 2012, it has been used to investigate 14 types of IRDs. A dozen of distinct pathological signs were observed in RTX-1 images. Hence, a classification of adaptive optics findings may enable to facilitate the detection of IRDs. And last but not least, even though only few follow-up studies were published so far, they already showed that the RTX-1 provides a sensitive method to evaluate IRD progression. This could be of interest for studying the natural history of IRDs, as well as for evaluating novel gene therapies. So here are the references of the papers used in this review. And many thanks to all the groups who contributed to this work, to the organizers, and thank you for listening.